So we're going to talk about scope, okay? And so again, most people should just realize this is a lot of revision. Scope is, of course, where code is valid, okay? Where a variable, where a function call is valid, okay? And so things in the same scope, they can be referred to a name or referred to by name, but that name must be unique, okay? So an object, a type, a function, a template, etc., okay? So we can't have two int i's in the same scope, but we can have int I and int j, okay? And scope rules are used by the compiler to determine if a piece of code is legal or not at any point in your code, okay? C++ has 5 different types of scope. There's local scope, which is anything that's between two braces, okay? So normally you see the braces when you're doing function calls, okay? But you can just arbitrarily put some braces in, and that creates a new scope block. You have a scope for function prototypes, okay? So function declarations. You then have a function level scope, okay, which we'll clear up very briefly. It's only used for goto labels. You have namespace scope, and you've got class scope. And scope in C++ starts from its point of declaration. What that means, and say I've got int I here, I can't say int I is equal to j, because j hasn't been declared at this point, okay? J is non-scope. I can say void f, okay, declare a function void f, but I can't call g, because g hasn't been declared at this point, okay? This is different from if you're coming from Java. If you're coming from Java, the second bit with void f and void g works fine, okay? Now, again, I should actually have this on the next slide, I don't know. To make this g bit work here, I can, up on level 3, which is line 3, which is currently missing, I could say void g, open, close brackets, semicolon. Do the function declaration at that point, and then this code will compile. Okay? But just doing it like that will not compile. Whereabouts in Java, it will. So be very careful if you're coming from Java. Stuff that you think will work won't. So let's talk about local scope. Okay? Each one of these braces is a new level of local scope. So I have void f, and it's got int I in it. I then say for int I equals 1. I've now got a second int I. Okay? Down here I've got int I again. I've now got 3 different int i's. They're actually sitting in 3 different scoping blocks. Okay? And what happens is in these second and third scoping blocks, for I here hides for I back in this previous scoping block. Okay? Now again, this is probably a little bit of dumb code because I probably wouldn't want to have multiple declarations of I because I'll get confused about which one I'm using. Okay? But be aware that local scope allows you to hide variables. Now I'm also pretty certain that for warnings completely enabled on G++, it will give you a warning for that. Okay? But maybe not all the time, so be very aware of that sort of problem. Okay? What you can also do inside local scope, you need to be aware of, is things like this. So as you saw that at local scope declaration of int I, okay? So I can do this in both C++ and Java. For unsigned int I there's some whatever, fingers.size plus I. Okay, and then I is declared inside here. Local scope in C++ does work different than Java and to a certain degree C in this way. If int I is equal to compute value, okay, do something here, else I is still valid inside of the scope, still the same scope. Okay? Now it's not valid outside of the scope down here, okay? But this I in this else statement is still in the same scope as this if statement up here. Okay? This is completely valid in C++. Which means if in that else statement I then tried to declare another variable called I would get a compiler error because now I would have 2 i's in the same scope. Okay? Okay, so we've done local scope, now we're going to do prototype scope. Okay, so we've got 1 down, we've got 4 to go. Prototype scope. These three declarations up here are all the same. Okay? When you're declaring something, you don't have to give it the name of the variables. You just need to give it the types. Okay? So void f int int is a function f, it takes into ints. Void f int a and int b is the same declaration as the one above. Void f int a is still a valid declaration at this point. Probably a dumb declaration, don't do this, okay? But this is still a valid declaration at this point. Okay? And also, again, this code compiles because you can have multiple declarations of things, multiple declarations of the same thing. It's only you've got to have one definition of it. Okay? So if you want to declare the same void f function 3 times, you can do that. You've only got, when you define this, only got one f function at this point. Okay. So 2 down, 3 to go. Function scope. Don't ever do this. Function scope is used for labels. Okay, so see it's found sitting here. This is a label. Okay, it's visible inside the entire function. Okay, so if there was void f up the top of here, and this is a one-side one function, this completely works, and you can say things like go to found. Okay, but don't ever do this. Don't ever use go to found. Okay, don't ever use go to. Okay, just forget this exists. You've seen it once, now forget it exists. Okay. So it is a type of scope, okay, but goto just breaks things. It breaks the stack. It causes you all sorts of grief. Don't use goto. Okay. 4th type of scope, namespaces. Okay, this is probably going to be new. Okay. Namespaces work very similar to Java packages. Okay. They allow you to put a group of related functions and variables and all sorts of stuff together into one place. Okay. So you can do something like this. You can have 2 different classes or files, C++ files. Both define a class called matrix. Both declare what pi is. Both has a function called inverse. Okay. But because these things are put inside this namespace, so namespace vendor 1, namespace vendor 2, these things compile completely separate, completely fine. Okay. It prevents clashes. Okay. If the namespaces didn't exist, you would end up with all sorts of problems about this. You'd have 2 definitions of the class matrix. You'd have 2 different definitions of the value pi, 2 different definitions of the function inverse. Okay? So namespace allows us to package up together parts of our code that works together. Okay? Namespaces can be nested. Okay? So I can have vendor 1, like namespace vendor 1. I can have inside that namespace product 1. In that namespace, so product 1 namespace, I can create product 2 namespace under the same vendor. Okay? Namespaces in the standard C++ library, okay, are defined in what's called std, so standard. Okay? And what you'll notice pretty quickly is we hash include iostream.h. Okay? And we start putting standard in front of cout and out in front of endout. We hash include vector. Okay, this will be next week. We hash include vector. Vector is also part of the standard namespace. Okay, and so when we want to use vector, we do standard vector. Okay, so you've got an iostream.h file somewhere. You've got a vector.h file somewhere. They both have namespace standard in front of them. Okay, so you don't have to declare it all in one point. Whereabouts with local scope, you had to declare that. You can't go out of that local scope, open up a different scoping bracket, and be in the same scope. That doesn't make sense. Okay. Namespaces do continue on. Okay, there's 2 special cases of namespace. There's the global scope, okay, which is the outermost namespace of a file. Okay, so that's where you haven't said namespace at all. You then have what's called file scope, which is the namespaces inside a certain file, and these are unnamed. Okay, so instead of saying namespace something here, namespace. Namespace, and then these 2 files, these int i's, work separately. Okay. This is preferred over if you're coming from C, where you've got the word static. Okay. Okay. So we're clear on namespaces so far. Clear on scoping. Okay. So again, this is going to be a slide on what not to do, but you can do a thing called using directives, okay? And so when we hash include iostream, for argument's sake, so actually the code up on this left, right-hand side here, I have the standard cout sitting here, okay? Now you understand the standard is using the standard namespace. The colon operator is resolving that namespace, and cout is a function within the standard namespace. And I end up with a lot of code putting standard all over the place, okay? You can get around this, and you'll see a lot of code does this, even the textbook might do this, doing a thing that's called this, using namespace standard, like that, okay? And now I don't need to put standard in front of cout. Everything gets pulled in automatically, okay? However, the problem that we've got at this point, and the reason why we don't recommend you do this, particularly do not do it in header files, is you pollute your namespace. What you've done is you've said everything that's in standard, just put into my namespace, bring into my same scope as I'm in. Which actually, this swap example is very good. There's a standard swap declared. When you say using standard namespace here, you don't know at this point, is that going to call now your version of swap or the standard version of swap? Whereas before, if I wanted to call standard swap, I would have done it like that. Okay? So for using namespace standard stuff, very, very carefully. In fact, don't use it at all. If you only want to use certain parts of it, okay, so say you didn't want to pollute your namespace, you can do this. Say if you only want to use the cout bit. Using standard cout. Okay? And that means that cout can work like that, but then I still need the standard inline over here. Okay? If I wanted to not use the standard inline, I can go up to here and say using standard and down. Okay? And still be very, very, you can use that if you want to, but be very, very, very careful about using that sort of stuff. Okay? Because you end up polluting your namespace in ways that you don't realize. Okay? Here's an example on the left-hand side. So namespace clashes. I have namespace X. It's got an int I, j, and k in it. I also have a k as a global variable. By the way, don't have globals, but I've got a k as a global variable. I have int I inside main, so a local scope here. Now I've got int I inside main. I then say use namespace X, okay, so make I, j, and k there. Make them visible at this point. If I say I++, I don't know if that I or that I is going to get incremented. In this case, local I is going to get incremented. If I say j++, well, it figures out that's the namespace up there and goes and does that. If I say k++, it doesn't know if it's that k or that k. Okay? I can resolve these by using the scope resolution operator. So for colon like that with no namespace means go use the global one. For x colon means go resolve that one. This code will look a whole lot better if that using namespace X was missing from there and you just used the scope resolution operators the entire time.